Okay, hello, this is a quick tutorial on section 7.2 ionic bonds, unit 3, lesson 2. Okay, when we talk about ionic bonds, we are talking about using a cation and an anion. Cations would be the metals, and so this would be cation. Metals, these would be metals, but for the representative, and these would be form anions, which are nonmetals. Okay, and I'll click them in another color right here. Okay, ionic compounds are composed of cations and anions. Cation has a positive charge, and anion would have a negative charge. Okay, they're also composed of metal cations, non-metal anions. Although they are composed of ions, the ionic compounds are electrically neutral. That means that the total of the cations and the anions, the charges, would equal 0. Okay, so the total charge of cations and the equals the total charge of the anion. So if we look at sodium chloride, sodium is a cation, it has a positive charge. Chlorine is an anion, have a negative charge. And notice if we would add up the charges, we have one sodium, that's a +1, plus one chloride, which is a -1, and so therefore the net charge is 0. Okay, and so the questions here are lithium and sulfur likely to form an ionic compound? Remember, an ionic compound forms from a cation, okay, a metal cation, and a nonmetal anion. Okay, so we would look at this, and we'd take a look at lithium. Lithium is over here. That's group 1A, and so that will form, it will tend to lose electrons, form a cation, whereas a sulfur would be an anion. Okay, it's a nonmetal, and so therefore a metal and a nonmetal is an ionic compound, and so this would be likely to form an ionic compound. Let's look at another example. Oxygen. Okay, we'll look at oxygen and sulfur. Okay, oxygen is in group 6A, and so is sulfur, and they are both nonmetals. Okay, both are nonmetals, and so they would form ions. They would form anions, and so they would not. Remember, an ionic compound is a metal and a nonmetal, and these are two nonmetals. And so this would not form an ionic compound. Take a look at aluminum and oxygen. Aluminum is in group 3A. It will tend to lose 3 electrons, and so that would be a metal. Aluminum is a metal, and this is a nonmetal. And so, yes, this would form an ionic compound. So to determine if it would form an ionic compound, you would need a metal and a nonmetal. The metals would be from this area here. Okay, these are the metals. We'll just go up to, we usually just do up to that. And nonmetals would be this section here. And let me just point to them. These are nonmetals. Now if we look at another one, fluorine and chlorine, that would not. Okay, they are both nonmetals, and they would not form an ionic compound. So they are not likely to form an ionic compound. Okay, so the ionic compound is a result of a transfer. Okay, a transfer of electrons from one set of atoms to another. And the ionic compound consists entirely of ions. And the ionic bond is that electrostatic force. Okay, we have a plus and a minus, and that plus and minus are attracted to each other. Opposites attract, and so therefore that is the basis of the ionic bond that holds these ionic compounds together. Okay, if we look at sodium. Sodium, this is the electron configuration for sodium. In the third energy level, highest energy level, it only has one electron. It's most likely to lose that electron. Again, now we have the next level down has 8 electrons. So sodium will lose that electron and therefore have a positive charge. It loses 1 electron. Sodium has 11 protons and now has 10 electrons. And so it's going to have a plus 1 charge. Whereas the chlorine will gain electron. Chlorine, this is chlorine. Chlorine has 17 protons, 17 electrons. If it picks up another electron, it will have 17 pluses and 18 minuses. It has an extra electron, and so it's going to have a -1 charge. So that's why the chlorine has a negative. Okay, so it's a transfer of electrons. We have sodium losing 1 electron, and the chlorine is picking it up. It goes 3p5 to p6. So it gains an electron. And now it has that plus and minus, and that attraction holds it together. If we look at magnesium, magnesium is in group 2A. Magnesium is in group 2A. Therefore, it's going to lose 2 electrons. It has 2 valence electrons. Going to lose those electrons, and so magnesium is going to have a +2 charge. Chlorine is in group 7A. It has 7 valence electrons. It's easy for it to pick up that 1 electron to form 8. So it gains 1 electron and now has a minus charge. The formula unit is magnesium chloride. If we put it kind of on a little scale, okay, and we want to kind of balance it, magnesium has a +2 charge. We're going to need 2 chlorines to have a total of a -2 charge. Okay, remember when we add them together equals 0, a +2 and a -2. Okay, so that's why we would need 2 chlorines for every 1 magnesium. Okay, we have 1 magnesium to 2 chlorine. If we look at aluminum bromide, aluminum is in group 3A. It has a +3 charge. Bromine is in group 7A. It's going to have a -1 charge. So we're going to need 3 of these. Have a total of a -3 here, +3 here. And so that's why we have this formula unit, AlBr3. Again, total net charge in the whole thing has to equal 0. +3 plus a -3 equals 0. Okay, here we have a couple of using electron dot structure to predict the formula. And again, here we have potassium and oxygen. Oxygen has 6 valence electron. It has kind of like 2 parking spaces to have 8 electrons. Okay, and potassium has 1. It loses 1. And so you have 2 potassium, so 1 would go here and 1 would go here. Okay, so like say this would go over here and this would go over here. So you have the potassium have a plus charge, and oxygen has 2 extra electrons, so it's going to have a minus charge. And you would write that K2O. And again, if we would do it this way, we'd look at potassium's going to have a plus charge, oxygen's going to have a minus. So +2 plus -2 is equal to 0. Same thing happens here. It's a little more complex. Magnesium is going to lose 2. Nitrogen is looking for 3. Okay? It has 3, let's say, parking spaces. 1, 2, 3. And so even if magnesium loses 2, we're going to need an extra one here. So we will eventually need 3 magnesiums for every 2 nitrogens. And again, if we look at that seesaw type of picture I draw and look at the charges, each magnesium is going to have a +2 charge because magnesium loses 2 electrons. It's in group 2A. Nitrogen has 5 valence electrons. It's going to pick up 3 electrons, so that's going to have a -3 charge. Now look at the total charge. We have a +6. We have a -6 here and a +6 here. And so we would write it this way: Mg3N2. And that's probably about the most complex we're going to get. Again, here we have +2, +2, +2. So that's a total of a +6. And here, whoa, error. There we go. And so there we have -3, and -3 is a -6. Okay, write the chemical formula. Calcium is in group 2A. It's going to lose 2 electrons, therefore it's +2 charge. Bromine is in 7A. It's going to gain 1 electron. It has 1 charge. For it to balance, and again we'll draw this little figure, for every 1 calcium +2 charge, we're going to need 2 bromide ions. See how it's a total -2. And we add them up as 0. Same thing when we have sodium and sulfur. Okay, sodium is going to be a +1 charge. Sulfur is a -2. We're going to need 2 sodiums for every 1 sulfur. And so this here would be CaBr2, and this would be Na2S. Now, aluminum and sulfide, again, that's just like the one we did before with nitrogen. Aluminum is +3. If we have 2 of these, that gives us +6. We're going to need 3 of these. Again, sometimes you have to play around with the numbers. So this is a -6, this is a +6, and so this would be Al2S3. That would be the compound. Okay, here we're given the formula, and now we have to write the compound. Okay, so here we need a periodic table. Potassium is K. It's in group 1A. So it's going to lose 1 valence electron. It's going to have a plus charge. Fluorine is in group 7A. It has 7 valence electrons, and it's going to gain 1, and so a minus. So now we have the cation and anion charges. So we have 1 cation for 1 anion. The formula is going to be Kf. We look at magnesium. Magnesium is in group 2A. It has 2 valence electrons. It's going to lose those 2 electrons, so therefore it's going to have a plus 2 charge. Bromine is in group 7A. It has 7 valence electrons. It's going to gain 1. So now we look at this. For every 1 magnesium, we're going to need 2 bromide ions. Look at aluminum. Aluminum is in group 3A, so it's going to have a plus 3 charge. Nitrogen is in group 5A. It has 5 valence electrons. It's going to pick up 3. And so this will be ALN. Okay, and the last part I thought I'd just talk about, monatomic ion. Ion formed from a single atom. Polyatomic ions, 2 or more tightly bound atoms carry a charge. These travel as a group, okay? They kind of stick together as a gang. Here we have some monatomic. These are monatomic here, just 1 atom. And then polyatomic, more than 1, would be the blue checks. And they travel as a kind of like a single unit. So I hope this brief tutorial helps you out. And you can click off.